Okay, are you with me? Hello? Hello? Are you hearing?
Yes, we are here. We are indicating with thumbs
Okay.
up.
Okay,
Mm.
deviation. That's deviation for the mathematics for economics course at upper level or for public policy analysis is to provide the student with the mathematical tools and skills necessary to understand and analyze economic phenomena. This includes developing a deep understanding of mathematical concepts such as calculus, linear algebra, statistics, as well as their application to solve economics problems. The course aims to equip students with a quantitative skills need to conduct a rigorous empirical research, build and interpret and do the interpretation of economic models, and make informed policy decisions. So by mastering these mathematical techniques, students will be better prepared to address complex economics issues and contribute to evidence-based public policy analysis. So one of the key factors that this course will lead us to is how can we apply some mathematical tools like calculus, differential equation, integral calculus, Riemann pair, and solve and analyze what an economics problems. So let's go to the next slide. So here's a description of the course. This is a graduate course in mathematics for economics analysis at M with MA or PhD student with background in both mathematics and economics. So one of the key concepts that will guide us in the study of mathematics for economics is to link the knowledge that we have for both mathematics and economics. How can we take an economics problems, use a mathematics as a tool to do the interpretation of such problems? So most of the problem of solving the population growth, the national income, the revenue, and other and most of the economic tools has to pass through the mathematical interpretations. So such method of interpreting mathematical economic tools is what we often call a mathematical models for economics. So the course consists of three sessions. Section number one, we first introduce some of the concept of linear algebra. Uh, in rewriting economic terms in terms of linearity, that is, in most cases, when economics problem pass through an interpretation or representation of a straight line concept. So in such a way, we use a linear algebra to do the interpretation. Some of key concepts under this are what? How can we rewrite an economic terms in form of matrix notation? How can we rewrite it in terms of linear equations, simultaneous equations, and also n terms equations? So any economic terms that has a linear properties. So we rewrite it is an economics model. It is mathematical model for the interpretation in terms of what linearity. So that's why we introduce the first concept to be what the linear algebra. Second part, we devote into multivariate calculus and constraint statistic optimizations. Uh, in calculus, some of the economic terms possess a scenario or the properties of what? Integral or differential calculus for interpretations. So in such situation, we use what the concept of multivariate calculus and constraint optimization in order to what? To model the economics problems. And lastly, we provide an introduction to what? A differential equation and dynamic systems. So in this last part, there is some economic factors that require what? A rate of change within a so class of intervals. So whenever we possess and economics problems that is changing either period, either at also time with respect to the increase or decrease of the what the goods that we are given to. So we need to take a look of what a mathematical model in the form of what differential equation or dynamic systems. In dynamic systems has to do with fluid dynamics. That is like in solving a problem with unsteady flow, or even the kind of use of three-dimensional flow. So we use what the introduction of differential calculus in order to do the interpretation of such problems. So in general, the course aim to take an economics concept, write a mathematical model, that is, rewrite the problem into a mathematical concept. If it is in section 1, try to find a suitable linear expression that can what do the interpretation of the economics problem. If it requires a different change scenario within an interval, we use multivariate calculus. That is, either use integral calculus or differential calculus in finding the solution or approximation of that economic phenomenon. So if it is also require a differential equation, then we use what the techniques of differential equation. Like this and also arise in solving most of the epidemiological problems, like in testing the HIV model, the tuberculosis, the immune response, and most of the economics model pass through the method of the representation of what differential equation. So let's move to the next slide. These are the instructors. I am Junaid Nafi Umalam. The assistants is Kamal Ahmad. So let's go to the, so these are the schedules that we have. Move to the next slide. So the textbook that we devote to for the student to go through for better understanding of the concept is The Mathematics for Economics by P. Barton and Rowe, Manchester University 2012. The one that we use here is the second one, which is Simon and Bloom, Mathematics for Economics. W. Newton, 1994. So another one which is also applicable to the course is Geoff Renshaw with contribution from Neyman Island, Mathematics for Economics, Oxford University Press. So I'm also advising the candidate or the student to go and look for HK Dance Advanced Engineering Mathematics. Is also applicable to this. So let's move to the next slide. So these are the prerequisites. Students are expected to familiar with the material covered in chapter 2 to 5 and A4 in the Simon and Bloom. So we just move to the what the main details of the subject. That is, we just start with chapter 6. We do believe that every candidate here has familiar with chapter 1 to 5, which are very simple to handle. So let's move to the next. So exercise, a set of assignment will be distributed through the semester weekly. So at end of the Friday class, I will distribute the assignment for the student to do. So this will count toward the grade and solution will be posted on the course website. So let's move to the next. So this is the assessment. There will be one midterm test and a final exam as usual. So the exam date the midterm and the assignment cover 60%. The final exam take 40%. No make-off test or exam will be given unless acceptable reasons can be provided by the institute. Less academic conduct. It's a student responsibility to familiarize with the HDI Academic Code of Conduct. Cases of academic misconduct will be referred to the what? Management office. Course outline. So here we give subsection of the course outline. That is, we take week 1, week 2, and week 3 course outline. Week 1, we dealt with linear systems, system of linear equations, matrix algebra, and determinant functions. So let's move to the next. The second week, we deal with Euclidean space. How can we represent a vectors or a number of commodity in terms of what Euclidean representations? How can we solve a linear dependence and linear independency, and also test the basis for independency of the given set? How can we solve a vector? How can we define a vector space in numerical example? How can we also take any vector or two different vector in a domain of a given function and define a linear transformation of such vectors? And what will be the output of these vectors? For example, if we take an empty set X, we call it a vector X that contains a set. We also take another non-empty set Y. Then how can we define a linear transformation that associate these two vector spaces? This is what we often call a linear transformation. So we look down the property of linear transformation of vectors. What are the conditions necessary and sufficient for any two vectors to satisfy a linear transformation? We also divide a vector representation into parametric and non-parametric equations. With 3, we take an eigenvalue and eigenvectors of the matrix, the inner product, and more especially num spaces, and how the applications of this num space can be equipped into economics problems. How can we take an incomplete nonlinear space and prove it by what? The completion. How can we also take a metric or any kind of metric like B metric space or contraction mapping principle and take an economic problems and show the proof? So we also devote the application to economics. So let's move to the next slide. So this introduction to linear algebra. The analysis of many economics models reduced to the study of systems of linear equations. Furthermore, one of the most frequently studied economics models are linear models. Here, we demonstrate the simple possible systems of equations called linear systems. So, before taking into details of the linear system, I would like to give a proper introduction on linearity of a model. So most of the simplest economic model or any mathematical model that you know is said to be a simple model whenever it can be written in terms of what linear system, because you don't have much tasks to solve. So most of the complex problems has to deal with what differential equations that possess different method of solutions. So in linear systems, we have different methods of solving the linear systems. Whenever we have maybe we have a product X, we introduce another different product. We call it Y. So how they relate? So to show their relationship, we have to rewrite the product in terms of linear equations. Then we take the product X, we relate it with product Y, and what is the output? We take product X1 and then Y1, and what is the output? We also take another one which is X2 and Y2. We also relate them together and we check the output. Then we ask yourself, if X has so quantity, then we can be able, with knowing the quantity of X, we can be able to determine what the quantity of Y. With knowing the quantity of Y, we can be able to find the quantity of what X and vice versa. So this is what we call what the linearity or the linear model. So this kind of equation, as you can see, the typical linear equations. We just write X plus Y. We just write X plus Y equals to 4, and 3X plus 6Y equals to 8. So this system has different techniques or different method of solutions. So the task here Not understanding only the linear representation of this, but what are the methods required for solving this system. Sometimes they may ask you to use what? The simultaneous linear and the equation to solve at elementary level. Sometimes they'll ask you to use what? Matrix inversion method techniques. Sometimes they may even ask you to use some softwares for testing the what? The equations, or you even use graphical representation to solve to tackle the problems. So this is the most simplest linear representation. It is very simple to handle. So they are called linear because their graphs are what? The straight lines. So whenever you form a graph, you take the given point, let's say x1, x2 up to n tuple, up to xn. You also take y1 up to yn. So whenever you have this, then the solution is said to be linear whenever you plot a graph and you find that the point of the intersection are sitting in a straight line. Then we said that the solution is said to be what? Linear. But if you have quadratic relations, it has to look in what? In curved shapes. So in general, an equation is linear if and only if it has the representation x1, y1, x2, y2, x3, y3 up to xn, yn equals to bn. So let me see if I can be able to use the whiteboard. Sorry, let me show the screen to the classroom board if we can be able to show some illustrations. Are we okay with that? Can we Can I do some illustration on the classroom board here?
Yeah, you can.
Okay, let me see if
That would be
the
good.
light is. I hope you are seeing the board, right?
Do I need to stop sharing my screen?
No, you can leave it if they can. I hope this is enough for us, right? Are you seeing my the whiteboard here?
Yeah, we are seeing it.
I don't have red. Let me see if this one can. So this is so what we mean by the linearity of a function of the economic model has to pass through the linear system before we take a proper interpretation of the model. So we said that let x and y be any variable, x and y be any variables. So let's say we take this in a vectors S. Are you seeing this? I think it's not clear. Are you seeing my writing?
Okay, you can let her share your board. Let her share yours. She should stop sharing the.
Okay, stop. You can stop sharing the.
So yours will now be larger that time.
Okay, so let's see. But I think it will still be the same.
So you can share your own now. Just share yours.
Okay.
Yeah. Click on the. Yeah, click on those three dots and then share your screen.
Don't worry.
Mhm.
But I think it's still showing the same.
You can manage it.
I think it's still the same.
But we are not seeing you again. Oh.
No, don't
Okay.
worry, you will see. I think it's still the same. So let's. What up now?
I'm seeing you.
The is the marker that I'm using. I think is. Are you seeing the writing is not?
Yeah, that zigzag is very clear. But the ones you wrote up, the
It's not see.
but this one you wrote now is very clear.
I'm supposed to have. I think the red marker will be broken. So see what I'm trying to explain. So let's assume that we have an x and y index like this, xi and yi. Can we see it here?
Yes, very clear now. Very clear now.
So if we have this index, then we said that this two variable is said to have a what? A linear representation. If whenever we can be able to write x1, y1 plus x2, y2 plus x3, y3 plus dotted line plus xn, yn equals to a constant, let me call it b index. So whenever you have an economic model, is it clear like this?
Yeah, it's clear. Very clear.
Okay. So whenever we have a representation of this scenario, we have an index representation of this, then we said that this function, this polynomial is said to be what? Linear. So what is determined what the linearity of a function is that whenever we have the unknown variable xi and yi, such that these xi are sitting in the vector space x, and that if there exists an integer m such that the power of this element of the vectors xi to the power of n dot yi to the power of n, provided this n is equal to 1, then we said that this representation is said to be what? Linear. Do you get what I'm trying to say?
Yes. Okay.
So the generalization of this linearity is, so we can take a nice, I think this is an index where our I is taking 1, 2 to what? Up to n tuple. Are you seeing it here?
Yeah.
So now, if we take the sum, the generalization of m tuple, since I is an index, we are not fixing what? I. So we take this first term, x1 and y1, we are fixing what? I. We are fixing both x and y variable, right? So we take
Yeah.
x is 2, x2 and y2 at I equals to 2, we are fixing also what? Y and x variables. Are we there?
Yeah. Yeah.
So if we take in relation, we take I equals to 1 to n of the element xi and yi. So this representation is set to be what? Linear. Whenever there exists an integer n belong to a natural number such that the power of the index xi and yi all to the power of n, and that n equals to 1. So any finite sum that we take, even finite or infinite sum, then this finite or infinite sum is said to be what? Linear representation. I hope it's clear.
Very clear. It's clear.
So therefore, assuming that we are fixing, assuming that we choose our n to be equals to 3 and I to be equals to 2. If we take n to be equals to 2 and I to be equals to 2, which system of linear equations do we have? Is it a linear equation or what? Class.
Oh. The example
We
we
are not
have,
following, right?
the example we have are similar, but this one, they are not. They are dissimilar. Why?
That is why I said a system is said to be linear whenever it has a representation of I equals to 1 to even if we take infinity, it doesn't matter.
Okay. Okay.
Where x has an index of I, y also have an index of I, such
Okay.
that I taking a number from 1, 2, 3 up to, we can either take infinity or we also define our n to what? To a finite number. Let's say 1, 2, 3 up to, let's say 10, for example. So assuming that I
Oh,
fix my n to be equals to 3 and I choose my I to be equals to 2,
yeah, it's
is
still linear.
the,
It's still linear.
some say it's still linear. You don't understand what I'm trying to define here. Let me take it once again. Let me take it once again. What I said, most of the economics phenomenon or the economics problems has to pass through what the linear systems in order to what to solve to do the interpretation of the problems. Are you with me?
Yeah, we're
Hello, class. The essence of mathematics for economics, math for economics, is what? We take an economics problem. Economics what? Problems. That is our key concept. What is our research questions is to what? To take an economics problems, right?
yeah.
So if we
Yeah.
take these economics problems, how can we rewrite it in mathematical problems, in mathematical representation? Are you with me?
Yes, sir. Yes, sir.
How can we write it? We take an economics problems. For example, let's say we want to model the devaluation of currency in Nigeria. So our research question is what? How to resolve the problems of devaluation of currency in Nigeria. That is our economics problems.
Yeah.
Are you with me?
Yes, sir.
For
Yes, sir.
our concern, we want to devote the skills of mathematics in order to solve this problem. There's the one scientist that says no any scientific phenomenon can be proved or can be assumed to be scientific without passing through what? The knowledge of mathematics. So since this is an economics problem, we mathematicians, we try to figure it, to visualize it in mathematical concepts. Let's say we call devaluation, let X be a devaluation of currency. Let this to be devaluation of currency. Devaluation of currency. For example, right? We also define our Y variable to do what? The solutions to the problems. So you see, we take an economics problems here. We are trying to do the interpretation into what? Mathematical concepts. Are you with? I hope this method is clear for us.
Yeah, it's clear. It's clear.
So now, if we can be able to write a mathematical concept, what we need to do is what? To analyze. We then analyze. We try to analyze, interpret, do the interpretation, even if we can be able to symbolize the problems. So we try to what? To solve these mathematical problems and do the interpretation into what? An economic concept. This is what we need in mathematics for economic class. So the question that I ask here is, we said that it's a problem. We said that a system of linear equations is said to be linear whenever it can be written as what? I equals to 1 to n xi yi, such that I is taking an index. Let me even take to infinity. If I take this to infinity, where my I is going to 1, 2, 3, up to what? Up to infinity. Do you see the interpretation?
Yeah. Yeah. Yeah.
So
Yeah.
now, the linearity of these expressions is depending on the what? The power of what? Our unknown variables.
Okay.
Do we see?
Yeah. Oh, it's not my phone.
it here?
Yeah, we're on.
Hello?
You were off a little. So you are using the power of 0 instead of the power of 1. Why, sir?
Okay. So the linearity of this system is depending on what the power. Sorry, somebody is disrupting.
Okay.
So the linearity of these expressions is dependent on what the power of the variable. So I said let's assume we take the summation of I equals to 1 to m. Let's say to infinity. Or let me choose a smaller number m, where m is a natural number. And I take x I and y I to the power of what? Mn. Such that my n belongs to the set of natural numbers. Do we see it? So what I ask you is this. Look at this, please. Are we seeing this?
Yes, ma'am, I've
So the
seen it.
question that I ask, if assuming that our n is equal to 3 and I equals to 2, is this expression linear?
No, I don't agree. It can't be linear.
Okay, that is very nice. So which type of system is this?
That's a polynomial, but I don't know. It's a polynomial, it's not linear.
It's polynomial. We agree that every expression is said to be polynomial, both linear, quadratic, cubic, quanta, and so on are all polynomial. Then which type of system is this? Okay, one thing that we need to do is what? We substitute this relation into our what? Expression. That is in our formula.
Okay.
Are we seeing it? So let me take it here. The light is not enough for us, then let's manage it. So let's substitute this. What is our solution? Then we said at m equals to 3 and I equals to 2, we have what? The summation. And the summation is taken from I equals to what? 1 is the position of what? I. Are we seeing it?
No, the what you have written now is off the screen.
Okay. So using the expressions here, as I equals to 2, then m is equal to what? 2. So therefore our new expression will be what? I equals to 1 to what? Where I is ending is 2. So we write what to 2. Xi, y what? I. Are we seeing this?
Yes.
Are we seeing this?
Yeah, the
Hello class.
it's only the y that is showing in what you have written now. Okay, XIYI is showing.
Yeah. Let me rewrite it. Sorry, Luca. And black. Are you saying this? I equals to 1 to what? M. What is M? Because we are mixing I here. So therefore our I equals to or our M equals to what? 2. So we take the sum from I equals to 1 to 2. Xi, Yi. Are we seeing this?
I.
Do you see it? So now we are fixing what? I equals to 2. So this will now be equal to, this will now be equals to, at I equals to 2, we have what? Xi, this summation is what? If we take this summational operator, we get x1, y1 plus x2, y2. Can we move to the next term?
Okay.
Can we move to the next term? No, because we fix our index I to be equals to what? 2. So now since we fix x to be equals to 2, we can write the summation. This has the representation of what? Summation of I equals to 1 to what? To m of xi, yi, such that I equals to 1 and 2. And m equals to what? I, where m equals to what? 1. So this is the representation. So if we have this representation, because I can give a wider explanation of this form, and I will ask you to write what the generalization of what is linear system. So whenever we are given what I equals to 1 to 2, then I equals to m. If I equals to m, then we can say then for this to be linear, m must be equals to what? 1.
Okay.
So from the last, the system is said to be what? Cubic. So we have different representation of the polynomial. So let me do it every time find it. So any system of linear equation of the form summation of xi, yi to the power of n and m. So let me just take n, both n. From I equals to 1 to m, then this system is said to be linear if n equals to what? 1. So whenever the power of the index or the index power of any given expression is said to be 1, then the system is said to be what? Linear. So
Okay.
look at this. For quadratic, we have a representation of what? Ax squared plus bx plus c equals to, let's say, b1. For linear, we just have, for linear, we have ax plus by, ax plus, let's say, c, let's say plus b equals to what? E naught. So for a linear, what is the highest power to the unknown here? Are we saying this?
Yeah.
What
It's
is the highest power to the unknown here? 1. What is the highest power to the unknown here?
one. It's just one.
No, this one is 1, but here is what? 2. For cubic, we have what? Ax cubed plus bx squared plus cx plus d equals to what? B2. So here, the highest power to the unknown is what? What is the highest power to the unknown here?
3.
It's 3, right? So since our highest power to the unknown here, n index is 3, then the system is not a linear, rather what? A cubic linear system. So many of the economic phenomena has these representations. So the system is said to be linear whenever it can be written in the form of what? Power of index 1. So the generalization of this system is what? A x1 y1 plus b x2 y2 plus c x3 y3 plus dotted line of the plus, let's say, a delta yn, let's say xn yn, and this equal to cx or c, one variable. So any system that can be written in this form, provided that their powers, their highest powers to the unknown is 1, then we refer the system as what? Linear system. So Chisom, you can share this slide. Let's continue. Okay, so this is what we call the linear system.
Please, please encourage Ifeni.
Okay, so as you can see it here, as you can see, this is a linear representation where the power of our unknown variable here is what? What is our unknown variable? They are called linear because their graphs are what? The straight lines. So in general, an equation is linear if it has the form. So this is the representation of linearity. So what is our unknown variables here? Hello, class.
X, have Y.
What is our unknown variable here?
Make I check it.
Is it X and Y?
It's X and Y. X and Y.
Do we have
Also
y
have,
here?
yeah, the second part we have A and X.
So look at this.
Okay, the
The
second
A
part.
index are the coefficient of the unknown variable x. So our unknown variable is what?
Is
Come to the, yes, down, 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 down. Yeah. So the unknown variable is what? X. Where A index are the what? The unknown variable, the coefficient. Do you see it? So
yeah,
the
A.
AI index are the coefficient of the unknown variables x, and B is fixed, where B is the solution of the what? The system. So the story of this system is the one of the simpler branch of mathematics. It requires no calculus, and at least in the beginning, very little familiar with functions. So let's move to the next slide. So examples of linear models. The reasons for looking at the linear system test is that some of the most frequently studied economics models are linear. So we demonstrate some models here as we develop our theory of linear systems. We will introduce, we will often refer back to these models and call attention to the insight which linear theory offers. So in this case, we take some of the main tools, main economics models, and we try to use what our knowledge of linear systems of equations and rewrite the system in such representation. So in the first one, we take the tax benefit of charitable contribution. So as you can see it here,
Please, Ifeni should mute his mic. It is just distracting us.
okay, so you see this is the system where there a company earn before tax profit of $100,000. Always understanding the question is the answering the question, right? Hello, class.
Yes.
Yeah. We're hearing you.
Always understanding the question is the answering the question. And most of these economics questions are very rigorous. So they require a deep thinking before what rewriting their exact mathematical models. So once you didn't understand the definition, it's very difficult for you to tackle how the nature of the model is. And what will come into your mind, whether the system require linear system, quadratic system, cubic function system, differential equation system, and so on. So it's dependent on the nature of the what questions. Because in the exam or in the CA, we won't tell you that this is the linear system to solve this. Rather than to write what the economic expressions. So you sit down and think, are you going to use differential equation to solve it? Are you going to use linear system? Are you going to use matrix method? Are you going to use Laplacian techniques and so on? So this is a certain company that earn before tax. what is earning before given tax is what? $100,000. It has agreed to contribute 10% of it is what? After tax profit to the Red Cross Relief Fund. It must pay a state tax of 5% of its profit after the Red Cross donation, and a federal tax of 40% of its profit after a donation, and the state tax are what are now said to be paid. The question is, how much does the company pay in the state tax, federal tax, and what Red Cross tax? So in this case, we have to do the computation of what the state tax, the federal tax, and the Red Cross tax. So with the knowledge of set theory, we know that in a given universal set, there exists a what? A subset of that set. So whenever we have set, there exists at least two proper subset, right? Hello, class. Are you with me?
Yes, sir, we are here.
We are with you, sir.
What I said, with our elementary knowledge of set theory, or let me call it the integrable functions, or even with our little knowledge of topology, general topology, right? And we have a little experience with the concept of general topology. Hello, class.
Yeah, knowledge.
Means law.
Can you recall a basic definitions in topology, topological vector space, or in a set theory?
Yeah.
So let's take a little bit of set theory. In any set, in any universal set, or in any given non-empty set, there exist two proper subsets. What are those subsets? Who can tell me? Hello?
Let me try with one. The empty
Okay.
set.
Yeah, that is very excellent. Who can tell me the second one? We want to use the idea here in clear understanding of the state tax, federal tax, and the Red Cross donation within the concept of topology or the concept of set theory. Who can tell me the second subset? I don't want to be writing much, but let me share the classroom board and see. Who can tell me the second? We have one on ground. The empty set is there. In every non-empty set, empty set is subset of that set. So what is the second one?
Okay, the empty set
The
is a
full
non
set. Okay.
If it's like you're saying something.
No, I'm just saying
Fine,
the
please
empty
go
set
ahead.
is a non set, right?
Null set is
Is the
also
empty
called an
set.
empty set. It's another name for the empty set. In every set, listen, in every non-empty set, so I fact empty set aside, I fact null set aside. So in every non-empty set, including singleton set, there must be a two profile subset of that set. What are the two sets? Chisholm has already said one correctly. So what is the second set? So let me share my 1 minute to explain the concepts for better understanding of this federal tax, the state tax, and the Red Cross donation. Can I write it on the board? Hello? Hello, class. Hello, class.
Yes, sir.
Can we write it on the board or I should give you as your home exercise?
No, let's write it. So we do it now.
Okay.
The two type of sets you are talking
In
about. You have
any
given us the two.
in any non-empty set, what we said,
Chisom mentioned the second one now. Chisom said, "Is it the proper set?" He mentioned proper set. Why
I
did
said
I
in
you talk
said
of
yeah,
null set?
okay, the
Empty set.
complete set.
excellent. So this is the second. So no need to write anything on the board. The complete set. So I'm advising the candidate or the student to go and read much on topology, how their representation is. It will give us a nice clue for understanding the concept of mathematics for economic class.
Okay.
So the empty set is there, and the complete set, that is the whole set, is also there. Maybe let me share the, Chisom, allow me to do some things on the board so for better understanding. So let me do a little explanation of the concept. Look at this. Assuming that we have a singleton set, let me say I have a singleton set. Let's say set x equal to contain an element. Let's say just an element A. Are we seeing this?
Yeah, we're
So we said that in every non-empty set, including what? A singleton set. The smallest set non-empty set is what? The singleton set. A set that contains only one element. So in every this in an empty set, there exists what two proper subsets. That is, there exists an empty set in a sitting in X, and the entire set is also sitting in what? In X. Do we see this?
seeing it. Yeah.
So the reason is that why do we say that X empty set is in this and the entire X is also sitting in X? The reason is this. If we take the union of this. So in every set, if this is an empty set, then it can be written as what? The union of empty union what? The entire set. Do we see it?
Yeah. Empty set union, the entire set.
Are we together? Are you with me?
Yes, sir.
So if we take the reason that we said that there, in every non-empty there must be two proper subset, at least two proper subset, that is empty and X, because if we take the union of the two, it will give us the entire X. Do you see the reason? Do you see the reason?
Okay. Okay.
Do we see the reason? So if X contains a single element X, then there must be what? The entire X. What X contains is only A. And what is the set of A? Is X. So if we take empty set in X, we also take X in X. If we take the union of the two, if we take X union, empty union X, it will also give us what? The entire X. So let's take another example here. Assuming that we define our set Y to contain two arbitrary elements, small x and y. Then in this is an empty set. Then there must be an empty set is a proper subset of capital X, and there must be another what? There also must be another element called what? X, which is also the subset of the entire what? X. So that if we take the union of X and X, we have what? We have X union what? The empty set will give us the entire X. So therefore, any non-empty set we take, the whole set, that is X and Y, is there in the set, and the empty set are also there, because at their union will give us the entire union. So for the clear understanding of this concept, we refer to what? The sum of the algebraic representation of this function. So let's back to our Teacher, help us share the
A moment, please.
help us share the it is so as we can see, the question asks us to do the computation of the state tax, federal tax, and the Red Cross tax. That is Red Cross donation, what the company is donating to the Red Cross, the federal level and the state level. So if we look at this problem, what would be the universal set here? Is it the state tax, federal tax, or the Red Cross donation? What would be the universal set? Hello, class.
Please repeat the question again.
I said, look at this example 1. Are we there?
Yeah, we are there.
So mathematics for economics is telling us always to visualize an economics problems into a mathematical concept, right?
Yeah.
So now this is an example 1. The tax benefit of charitable contributions is an economics problem, right?
Yes,
We
it
have
is. It is.
we have a company that earned before tax profit of 100,000. It has agreed to contribute 10% of its after tax profit to the Red Cross Relief Fund. It must pay a state tax of 5% of its profit after the Red Cross donation was made, and a federal tax of 40% of its profit after donation and the state tax are paid. How much does the company pay in the state tax, the federal level, and the cross donation? So if we visualize this in the set representation, we found out that the federal tax is our universal set, right?
Okay. Yeah.
Yeah. So the federal tax, we will make assumption and let the federal tax to represent the universal set, where the state
We're not hearing your voice again. No. Hello, Chisom, call him. Oh.
Okay, I will. It seems there's an issue with his network. He's not reachable.
I think somebody is calling him. That's why.
Okay. You just sent in a message and he lost connection.
Okay.
The class is supposed to end at 8:30. So if he doesn't come online at 8:30, I think we can end. Then we'll continue from where we stopped on Friday according to the timetable.
Okay. Okay.
It's 8:30. I think we can stop for now. For today, I mean. Then we'll continue from here on Friday.
I hope you will share this slide. You will share this session with us.
Yes, we'll share it.
Okay. Thank you.
Okay. Have a good night, everyone.
Good night. Thank you.